Hello everyone. I have another great video from Hervé Riboni to share with you today. As Hervé has discussed in prior videos, as part of the cabal's process to change our flat Earth reality into a globe, the controllers artificially enlarged the northern hemisphere and simultaneously shrunk the southern hemisphere. In other words, actual distances in the northern hemisphere are shorter than claimed by maps and the globe, while in the southern hemisphere, actual distances between points are further away in the east-west direction, but not in the north-south direction. The minutes of latitude are half than the official narrative on all of the flat Earth, which diminishes the circumference of the flat Earth. But this deception creates telltale signs of manipulation. For example, both false magnetic declination adjustments and time zones certainly hide these changes. I'll leave links in the description to Hervé's prior discussions on those topics if you haven't seen them. In addition to the time zones and magnetic declination deceptions, as will be discussed in this video, the cabal artificially enlarged maps in the northern hemisphere to hide their subterfuge. For example, as shown here by Hervé, if map scales were legitimate, a 100-kilometer road, although winding, would still match a 100-kilometer straight path, because the distances are the same. But it doesn't match. The winding 100-kilometer road is longer than the 100-kilometer straight line distance, and that doesn't make any sense on the globe. But the manipulation is much greater than what he's showing right here, because the actual road winds and turns much more than is indicated on the map. In short, the scales on maps are entirely wrong. To be clear, the controllers are not faking driving distances. That would be impossible to fake actual driving distances. Instead, they are taking road maps and artificially stretching them. You still cover the same distances shown on the map and on the odometer, but the maps themselves have been stretched in the northern hemisphere. As will be shown in the video, an actual sinuous winding road is artificially stretched on Google Maps and GPS to make it look like a longer distance. For example, look at the road on the left. It's sinuous, but Google and GPS will then stretch the road to look something like the road on the right, which is fascinating. This then creates the illusion on the maps that the driving distances match nautical miles flying distances when those distances do not match. In the northern hemisphere, that means that airplanes and boats which use nautical miles are not traveling as far as they think they are, because their speeds are wrong. Their official speeds work only on the fake enlarged globe map. In reality, they are traveling substantially slower on the small flat Earth. So, when you go on a drive in the northern hemisphere, the distances on the odometer are correct, and the distances on the highway signs are correct. The problem that you're going to see is the fact that the road is going to look much more straight on the GPS map than reality, because the road will be stretched to appear longer on the GPS map. These differences are substantial if you're looking for them. On the other hand, if the road was actually straight, then the Google and GPS maps would still stretch out the road further to make the road appear longer on the maps, but it wouldn't be noticeable to the driver. Again, this is done to artificially enlarge the road map to match the nautical miles distances of direct flights and boats. You can't hide the actual distances driven on a road, but you can hide nautical miles with respect to airplanes and boats. I'm going to play this small clip from Hervé's video that summarizes his argument.
In reality, the curves are really sinuous, and they are not objectively represented by the GPS of Google Maps. And we will see that the curves are much flatter on the GPS than in the reality. Obviously, it's to be able to artificially enlarge the map, compared to reality to be able to create the northern hemisphere of the ball.
Anyways, I'm now going to share the entire video by Hervé. Please be aware that there is a 30-minute section in the video where he films his driving on a winding road. It actually gave me a bit of motion sickness to watch the whole thing. Don't be afraid to skip that section if it bothers you. Although it's definitely worth watching, Hervé is just proving that the Google and GPS maps do not match the reality of the road, and I think he proves his point very well. But don't skip the ending, because Hervé goes into some detail on how they have manipulated distances in the southern hemisphere in the east-west directions, and why the flat Earth has a smaller circumference than we thought. A big thanks to Hervé for doing this. This took a lot of work. Anyways, I hope you enjoy it.
Hello, in this video we will demonstrate that the scale we use on road maps is completely wrong. For this research, we will study a route from Quebec to New Brunswick, but more precisely for the introduction between Saint John and Fredericton on Highway 7. We will see that the very winding road that we take by car covers the same distance as the direct road. The direct route is a marine term that you will hear in the video, which means a route as the crow flies. We will now see a very short version, the demonstration of the subterfuge of the distance on the road maps that we use, which will be followed in the video of the detailed explanation. So here we have on this trip the 100 kilometers by road well indicated on Google Maps. I can already confirm that the kilometers on the road are exact, and that is indeed the scales which is wrong, as we will see later. Now we are going to compare the distances on the road and the route as the crow flies. I will do it schematically. It will be done in a more precise way during the presentation, but so that we understand the system they use, the subterfuge. So I'm going to take a piece of cord and we are going to try to follow the route schematically on the map. So we start at the starting point and we follow the road with the cord. As I said, it will be more precise during the presentation, but we do it for the first time to understand the trick, to understand how does it work. So it's about this length. I now place it on the route as the crow flies, and we can already see that the 100 kilometers by the road arrive further than the 100 kilometers as the crow flies. We understand that it is already not logical, but what is much more important is that on a scale like that of the map, we do not take into account all the bends in the road that there is in reality, and the difference is huge. But obviously, all these bands exist, so I will need a much larger cord to follow on the map all the bands that exist in reality. If we try to draw the actual road on the map, as you will see, since I filmed the route while driving, so this road has a lot of tight turns. So the road here makes a lot of bends, and therefore all these bends, obviously, that must be taken into account. It is more distance than those drawn on the map. But let's not forget that the kilometers on the road are exact. So we will do the same demonstration with the cord, but obviously now we need a bigger cord. I would not do it all because it would be too long, but we understand that by following all the terms that exist in reality to have the real distance from the road, and this distance here is really 100 kilometers. You see here the blue cord is the one that follow only the turns drawn on the map, and the yellow cord is the one that I would really need to follow all the turns that exist in reality. So if I take the right cord now and place it on the route as the crow flies, well, the 100 kilometers that we did by road now arrives at least twice as far. So what does that mean? It means that first of all the scale is wrong, and we understand that to do 100 kilometers as the crow flies up to here, it becomes completely absurd and ridiculous. The right distance as the crow fly will certainly be less than 50 kilometers instead of 100 kilometers indicated by the map. So according to the official version, a plane that would leave from here at 100 kilometers per hour in 1 hour would end up here. But in reality, he has only done 50 kilometers, and therefore that means that it is flying at 50 kilometers per hour. The plane flies 2 times slower than the official version. As we have seen in the previous video, the manipulators have stretched the northern part of the flat Earth thanks to the magnetic declination, and they match the time zones with the Earth surface. It can also be noted that they match the zero line of magnetic declination, which are supposed to be random and time shifting, with the essential time zone in the northern part. As we see here, we have a 0-degree line on the Bering Strait. And we have a 0-degree line on the Greenwich Meridian. So the magnetic declination adjusts miraculously with 12 a.m. and 12 p.m. on the sphere. Now, if the real surface of the Earth has been artificially enlarged to conform to the sphere, it must therefore be understood that the flat Earth is much smaller. Manipulators like Bill Nye or Neil deGrasse Tyson always say the opposite of the truth. When they say it's a very big ball, it means it's a small flat Earth. Now, how can we move by car, plane or boat if the distances on the sphere are wrong? On the sphere, the reference of the distances for the trip by boat and plane correspond to the latitude. We take a compass and we report the distance from the point A to point B vertically on the latitude. And officially, 1 degree of latitude equals 60 minutes and 1 minute equals 1,852 meters. So if we take an example on the nautical chart, we will proceed in this way. We will take the length of Puerto Rico with the compass and we will transfer it to the latitude. Here we have 1 degree and 40 minutes. This equals 100 minutes, which equals 100 nautical miles or 185.2 kilometers.
C'est-à-dire 100 nautical miles, 100 milles nautiques, et ce qui équivaut aussi à 185,2 km.
On the sphere, there are 90 degrees to the north and 90 degrees to the south, which equal 180 degrees times 60 minutes times 1.852 kilometers equal a distance from the North Pole to the South Pole of 20,000 kilometers, which equal half the circumference total of the sphere. We can see it here on a sphere. We have 90 degrees to the equator, so 90 degrees north, 90 degrees south equal 180 degrees times 60 minutes times 1.852 kilometers equal 20,000 kilometers, which is logical for the sphere, that is 40,000 kilometers in circumference.
180 degrés, ce qui fait bien 20 000 km.
On the nautical charts, they are never the roads or they are so schematized that it is impossible to use them as road maps, and even less to compare the distances with the reference of the latitude. As here in Puerto Rico, there are some market roads, but it's really very schematic. You can't use it as a road map.
Et puis, vous pouvez encore moins voir tous les virages et les montées et les descentes. Donc, on ne peut pas l'utiliser.
On a road map, the reference is a scale in kilometers or in a road miles, which is not the same as the nautical mile. And it is the opposite of a nautical chart. On a road map, you never have the latitude as reference. As you can see on this road map here, they will help you locate yourself with numbers and letters and a lexicon, but they will never tell you the longitude and the latitude. There is therefore no way to easily and precisely compare the distances of the road with the route of the plane or the boat. Knowing the way of operating of the manipulators, one could easily see here something very suspicious, but we will still be able to compare these distances. And so for this comparison, we will use and observe a route that I have done a good 10 times already, which leaves from Boucherville in Quebec and which goes to Saint John in New Brunswick. It's a journey that is 881 kilometers. I projected the map on the whiteboard and I trace exactly the same route with the same scale. So we have a trip that is 881 kilometers from Boucherville at the intersection of the highways 20 and 30 in Quebec. So it's a very accurate point. And the trip arrives in Saint John in New Brunswick at the intersection of Highway 7 and 1.
Croisement de l'autoroute A7 et A1. Donc la 1 et la 7 au Nouveau-Brunswick. Donc ce parcours fait 880 km. Donc maintenant,
and now we are going to compare this route on a nautical chart.
Mais sur une carte marine. Voilà,
we have here a nautical chart of the area. And we have drawn a straight line from start to finish, like the path of an airplane, and as it is a nautical chart, the distances are referenced in latitude as we saw in the beginning. So for the distance as the crow flies, it corresponds to 305.12 nautical miles.
En route directe, ça nous donne 305,12 milles nautiques. Donc 305,12 milles nautiques.
Therefore, 305.12 nautical miles times 1.852 as we have seen to have the kilometers equal 565 kilometers. Now, this path is a perfect right triangle with a right angle at its vertex. And moreover, the two dimensions are exactly the same distance. Here I have 82 centimeters, and here the same thing, 82 centimeters.
Et ici, pareil, 82 cm.
So if we look at the two cathetes, which are the two sides of a right-angled triangle, we have a perfect right-angled triangle. So as we know Pythagoras, another Freemason, we can apply his theorem.
Donc comme on connaît ça, Pythagore, un autre franc-maçon, on peut faire son théorème.
So we multiply by the square the distance of 565 kilometers, which equals 319,225. We divide it by 2. We calculate its square root, and we obtain the distance in kilometers on each side of the right-angled triangle. Here I have added the distance of the hypotenuse, 565 kilometers. So it is this line on the nautical chart, and the kilometers of the two sides of the right triangle are 399.5 kilometers. So let's say 400 kilometers. So these distances are the distances as the crow flies. So maybe you already see the problem we have. A road with all the bends, climbs, descents, and which sometimes deviates from the road as the crow fly by more than 100 degrees, cannot having only 6 kilometers more, and even on this side, 75 kilometers is ridiculous. It will be much more than that, the difference in kilometers between the route as the crow fly and the road. We can already see here at first, if we take the scale which is 50 kilometers for 10.5 centimeters here, by applying 100 kilometers on the direct road, we arrive here. And if we unfold the 100 kilometers of the road on the direct route, we are already further than the 100 kilometers of the scales as the crow flies. So here, to better understand, we enlarge the first 100 kilometers starting from Saint-John in the direction of Boucherville. For the road, we have Google here with the mouth, which confirms that at this point we have done precisely 100 kilometers. And we have on this side, the scale for this map is 14.5 centimeters for 20 kilometers. We multiply by 5 to have 100 kilometers, which equals 73.5 centimeters on the whiteboard, which correspond to the 100 kilometers in direct route or as the crow flies. Now we are going to compare with my pizza cutter the difference in distance between the road and the direct road. I made a mark here to be able to count the laps.
J'ai fait une petite marque là, et on va pouvoir avoir une bonne idée de ce que sont réellement les différences de kilomètres. Ok, là j'ai un tour. Deux tours. Trois tours. Trois tours ici.
3 turns and 2 thirds.
D'accord?
And if we do the same thing on the direct route,
3 tours 2 tiers. Un tour. Deux tours.
3 turns and 2 thirds.
Deux tiers.
So we see that the 100 kilometers by road already arrives a little further than the route as the crow flies, which is impossible. But what we do not take into account here, and you will see after the difference with the reality, it is all the bends, the climbs, and the descents. In reality, we cover a lot more distances than the few bends marked on the map, which is large scale. But if I could make with my pizza cutter all the turns, climbs, and descents that really exist in reality, I would certainly have done at least 7 turns. And with 7 turns on my pizza knife, for 100 kilometers on the road, I would have gone twice as far on the direct route. You really have to be aware of the difference between the road map, where very few turns are indicated, and the reality, without forgetting the climbs and descents, and there are many on this road.
Et il y en a vraiment beaucoup sur cette portion de route.
Then, another important thing to take into account for the differences in distances between the two routes is also how many degrees the route
c'est
will deviate from the route as the crow
la
flies.
différence de degrés entre la route directe et la tangente qu'on va devoir prendre avec la route.
So we see
voiture.
that from the
Donc on voit
beginning
que
there are
dès le début,
15
il y a déjà
degrees
15 degrés
which deviate
qui
from
s'écartent
the
de la route
direct
directe,
route,
ensuite
then
45,
45, then 35,
25
then
degrés
25
pour cette
degrees
portion,
for this
des
portion of
475
475 kilometers
Donc,
of the journey.
On peut déjà
We already
comprendre
understand
que
that just with this
75,5
difference in degrees
kilomètres de
between
plus
the
que la route
road
directe
and the
vont
route
déjà
as the
être
crow flies,
dépassés.
the additional 75
Et on
kilometers
n'a pas encore
by road
tenu
that
compte
Google
de
indicates
principales.
are barely
C'est parce que ça,
enough
c'est toutes des
to
lignes
make
droites
up this
qui
difference,
s'écartent à un certain
and we
nombre
have
de
not
degrés de la
yet
route directe.
take into
Mais il faut
account
tenir compte
the
de tous
most
les
important,
tous les
which
petits
are
virages,
the
les
many
montées et
bends
descentes qui vont être encore
and
bien
the
plus
ups
importants
and
que
downs.
cette différence de degrés.
So this difference
Donc ça va être
will be
énorme à la
huge
fin, la
at the
différence
end of the
entre,
journey
euh,
between the road
la route
and the
directe
direct route.
et la route qu'on va prendre avec la voiture. Et
And
comme on a
as we
vu
will see,
que
we have
les
calibrated
kilomètres sur
the
la route
kilometers on the
étaient
road so they are
exacts,
accurate.
puisqu'on les a
This
étalonnés,
means
sur la route,
that
on sait que les
the scale
kilomètres qu'on
of
fait
the
sur la
road
route
map
sont
is
exacts.
wrong by a lot.
Alors, si les kilomètres sur la route sont exacts, ça veut dire que c'est l'échelle de la route directe qui est fausse, mais qui est fausse de vraiment beaucoup.
So
Donc, si,
if in
en
reality
réalité,
the
la
100
route
kilometers
directe,
of the
100
direct
kilomètres, il
route
n'arrive pas ici, mais il
does
arrive
not
2 fois
arrive
plus
here,
loin.
but
Alors, qu'est-ce
it
que ça
arrives
signifie?
twice as
Qu'un
far,
avion
then
qui
what does
officiellement
that
ferait,
mean? It
cette
means
distance, je
that
dis
a
un chiffre,
plane
au
which
hasard,
would cover this
pour
distance in
simplifier,
1
cette
hour
distance en
makes
1 heure de temps,
it
100 kilomètres en
there
1 heure de
the
temps,
plane
eh
just
bien,
did 50
en fait, en
kilometers
réalité,
instead of
100
100
kilomètres, mais 2
kilometers.
fois plus loin.
So the plane
Ça veut
is
dire que
going half the speed of the official
l'avion,
narrative.
il va faire 2 fois plus de distance. Et donc, au lieu de faire un 100 km ici, il va faire 100 km là-bas, 2 fois plus loin. Ce qui signifie quoi? Que l'avion, il va 2 fois moins vite que ce qui est officiellement que le narratif officiel.
Now we are going to look
On va
at
regarder,
what was
dans la
filmed
réalité,
on the
sur
road,
le terrain,
and
ce
there
qui
are
est filmé,
certain elements
sur la route.
to pay
Donc, il y
attention
a
to.
quelques points qui
So,
serait bien d'être
I
attentifs.
took several shots
Donc,
on this part of the
on a
trip
fait,
from
j'ai
Saint John
pris
to
plusieurs,
Rivière du
prises de
Loup.
vue, sur la première partie du trajet jusqu'ici, hein. Donc de Saint John à Rivière du Loup. Et donc,
And the
première chose
first
à
things to
regarder,
take into account
c'est de manière générale
is
la
the
physionomie
physiognomy
du terrain. Vous
of
allez
the
voir
region.
qu'il y a beaucoup de montées,
It is a
il y a
very
beaucoup de-
hilly
de
region,
montagnes,
so the highway has no
de
other
collines.
choice
Donc,
to
le
make a
conducteur
lot
est
of
obligé de faire
turns,
beaucoup
which,
de
as we
virages,
have seen,
beaucoup plus
are not
que ce qui est,
indicated on the map.
ce qui est décrit sur la carte.
You
Énormément
will
plus
see
de
tighter
virages, beaucoup
turns,
plus serrés
climb
aussi,
and
des
descents.
montées,
We
des
also deviate
descentes.
from the direct
Ces
route,
cartes,
so we
de
have
la
these
route,
parameters
directe.
to take into
Donc,
account.
il y a ces paramètres à tenir compte.
And
Donc, en
also,
termes
we will be
d'idées,
able to
on va
compare
voir
live
que
the
sur
bends
une
in
carte à grande
reality
échelle,
and
il y a
those
très
on the
peu
map,
de
the
virages
number
qui sont,
of bends indicated
représentés.
and the curvature of the
Comparativement, on va voir
bend.
dans la réalité, ça tourne et ça tourne aussi très serré. Beaucoup plus serré que les virages qu'on peut voir sur la carte. C'est très sinueux, beaucoup de montées et descentes. Il y a une chose aussi qu'il faut,
And the last thing to be
qu'il faut porter
careful,
attention.
we will see it
Ça,
live
on va
in
le
the
voir en
truck
direct,
while driving.
dans le camion
We have
en
the
roulant.
reality
On a-
of
on
the
a la
curves,
réalité, des
and
courbes,
at the same
et
time,
ensuite,
I
et puis,
take
en même
GPS
temps,
shots and we
prendrai
will see the
des prises de vue
difference
du
in
GPS.
curves.
Puis là, on va voir les différences de courbes.
In
Sur-
reality,
dans
the
la
curves
réalité,
are really
on
sinuous,
va voir que,
and
en
they are
tournant, les
not
courbes
objectively
sont
represented
vraiment
by
sinueuses.
the
Et
GPS
qu'elles
of
sont
Google
pas
Maps.
représentées
And we will
par,
see that the
le
curves
GPS
are
de
much
Google Maps.
flatter
Même
on
moment,
the
on
GPS
regardera
than in the
GPS,
reality.
Et on va voir que les courbes sont beaucoup plus plates sur le GPS que dans la réalité.
Obviously,
Évidemment,
it's to be
c'est
able to
pour
artificially
pouvoir
enlarge the map
agrandir,
compared to reality to be able to
artificiellement,
create the northern
la carte.
hemisphere of the ball.
Comparativement à la réalité. Donc, c'est de nouveau la différence entre le globe et la terre plate de la réalité.
The first
Donc, la
thing to
première
check
chose,
is
à
are the
contrôler,
kilometers
est-ce que les
on the road
kilomètres sur la
correct?
route
So what I
sont,
did, I took a
sont
wheel
justes,
to
sont
measure,
exacts, sont
which
corrects.
I calibrated
Donc, ce que j'ai fait en
with a
premier,
tape measure.
j'ai,
Then I
pris
measure
le
100
ruban
meters with the
mesuré,
wheel
un
to be
ruban,
measured, and I calibrate
j'ai
the
mesuré
odometer
les
of my
panneaux qui sont
car.
sur le bord de l'autoroute, voir
I
quelle
also
distance il
measure
avait.
with the wheel the
Ensuite,
distance between
je l'ai
some
étalonné
small
avec,
kilometer
l'odomètre
signs
de ma
on the
voiture.
side of the
Ensuite, avec ma
highway.
voiture, je suis parti,
And finally, I
sur,
did
sur
200
ce
kilometers
tracé
with
pour
my
200
car
kilomètres
on the route
pour
that I was
avoir
going to
la même
travel with the
route
truck.
qu'avec le camion.
And at
Et
the
donc,
end of this
au bout du
exercise,
compte,
I
j'arrivais
arrive
à
at a result
quelque
very
chose
close to
de,
the kilometers by the road, on the
de très
GPS,
peu
on the
différent,
map,
quelque
and
chose comme,
with the kilometer signs on the side of the highway, with a small difference of
ça peut aller dans la marge d'erreur,
0.25%,
ça. Là,
which
on peut
perhaps
sur le
consider the
principe
margin of
que, les
error.
kilomètres sur les autoroutes
So we can
sont
consider
justes.
that the kilometers on the highway are
C'est pas,
exact.
c'est
And
pas des
in
petites
any case,
différences
it
qu'on
is not
cherche,
a small
c'est une
difference
grosse
that we are
différence.
looking for, but rather
Et
a
ceci,
big
c'est
difference,
une
and the
énorme
file
différence.
scale is a huge difference.
Comme je viens de le dire, les kilomètres
And
sur la
we
route sont
recapitulate.
justes. Donc, ça
The
veut dire que
kilometers
pour
on
aller
the
de ce
road are
point-là à ce
correct,
point-là,
so
j'ai
that
bien fait
means
100
from
kilomètres.
point A to
D'accord?
point B by road,
Donc,
I have done
si
100
les
kilometers.
kilomètres sur la
And
route
if
sont
the
justes,
kilometers on the
ça veut
road
dire
are
que
correct, it means
l'échelle
that
est
the
fausse.
scale is wrong.
L'échelle est
Instead
fausse.
of being 100
L'échelle,
kilometers so
au
far
lieu
on
que
a
ça
direct
soit
route, in my
100
opinion,
kilomètres,
it will
ici,
be less than 50 kilometers,
ça va être 50
less than
kilomètres,
half.
la moitié.
That is to say
C'est-à-dire
that
que
on
pour
the scale
10,5
for
centimètres, au lieu de 50
10.5
kilomètres, ce serait 25
centimeters,
kilomètres.
it would not be
À ce
50
moment-là, ça mettrait
kilometers,
le 100
but
kilomètres
25 kilometers. And
Et ça, ce
in
serait
this
beaucoup plus
case,
logique.
that put the 100 kilometers twice as far.
Parce
That's
qu'il resterait que 100
logical.
kilomètres
You cover
à aller
half
ici,
the
donc
distance
à peu
by
près
road
la moitié
than by the route
d'une
as
route
the
directe.
crow flies.
La route directe des 100 km, ce serait ici. Puis lui, le 100 km par la route, eh bien, ce sera à peu près la moitié. Ça, ce serait logique. Comme vous allez
As
voir,
you will now see in reality
quand j'ai
how
filmé,
the road
sur
is
la route,
winding with a
comment
lot
la
of
route
up and
tourne et
down.
monte et descend.
We are at kilometers 93 on the highway A7. You see, oh, it turns and compare with the map on the left. You see that is not at all a straight line, the 7. And remember that it is this map that we measure the distance with the pizza cutter at the court. And compare with the GPS, as the curve is less sinuous on the GPS than in reality. We are at kilometers 80, bend to the right. You see that it does not look at all like the bends indicated on the map. You see how it turns tight on the right, and on the GPS the curve is flatter. We will see the difference of the curve between reality and the GPS. The GPS stretches the surfaces to conform to the globe. And now it goes down and it goes up. Another curve, big difference with the GPS. Look at the physiognomy of the very hilly terrain and no choice to have a very winding highway, and compare with the map on the left, and we understand that with all these turns, these climbs and these descents, the map is not representative of the difference in distance from the route as the crow flies.
l'autoroute 7, sur le GPS, quand on le prend à grande échelle, on a l'impression que c'est quasiment une ligne droite. On comprend qu'avec tous ces petits virages, ça fait évidemment beaucoup plus de kilomètres. Plus les descentes et les montées.
It does not stop turning, going up and down. And on the GPS, it almost does not turn.
Belle courbe encore.
Nice curve again. Look at the difference with the GPS.
Tourne encore énormément. Voyez la courbe. Regardez sur le GPS.
On the GPS, almost no curve, and the road takes the direction northeast, while the direct route is north-northwest.
La route c'est nord-nord-ouest.
You really have to be aware that a plane that would have left at the same time as us for the same route will always be perfectly on the route as the crow flies, and we, by car, are never on the direct route. Here the road makes an S, it goes left and right. Let's look at what the GPS says.
On va voir ce que nous dit le GPS.
Nothing.
Virage à gauche, on voit quasiment pas.
Look on the map for the stretch of road where we are, which is almost a straight line, and compare with reality.
À droite.
We arrive at the junction of the highway A2.
On arrive à la jonction de la 2. Ici c'est la 2. On va reprendre la 2.
So we are on the highway number 2 at the kilometers 280. Now we have the sun in front, we are heading west, and the direct route is north-northwest. And we will see that we will go down even to southwest.
Nord-nord-ouest. Là, on va voir qu'on va descendre au sud-ouest complètement.
We arrive in a descent. We are on the portion which is at 45 degrees from the direct route, and we have even start 25 kilometers to the southwest, which take us away from our goal at more than 100 degrees from the direct route. As you see on the GPS, we are moving away from the goal. You see here we are driving in the direction of southwest, and the direct route is north-northwest. So all the kilometers that we are losing now, we will have to redo them later. And moreover, at the moment, not only are we going in the wrong direction, but in addition, it goes down and we have bends. We see the sun is on our right now, and it's 4 o'clock in the afternoon. The sun is setting in the west, so we are going south-southwest, as you can see on the GPS. While we are going in the wrong direction, the plane is going in that direction, perfectly on the direct route.
Sud-sud-ouest. Et évidemment, on s'éloigne du but. Donc tous les kilomètres qu'on perd là, il va falloir les rattraper.
We have to go north-northwest, and here we still have at least 50 kilometers at 45 degrees from the route as the crow flies. Here we see the truck in the background. It goes down, it's still good downhill and uphill. Compare the map and reality. Look at the difference of the curve.
tourne ici, on se retrouve là-bas.
We can really see that throughout this portion of the journey, which is 475 kilometers, the road is very winding. Another nice turn. Let's compare with the GPS.
Moins serré.
Another curve. Here it's even more obvious. We have very flat curves on the GPS.
De rien du tout. Regardez. Ça tourne vraiment là. Ça va tourner dans l'autre sens. On voit que le S il est beaucoup plus plat.
Here we are in the direction of the northeast at 90 degrees from the direct route. At 90 degrees we are not advancing at all on the goal. So on the place where we are at the moment of about 2 kilometers, we are not approaching the goal, while obviously the plane is still in perfect direction on the goal.
Pendant 2 kilomètres, c'est comme si on n'avançait pas vers le but. Alors que, évidemment que l'avion, lui, il est tout le temps en parfaite direction, directement sur le but.
We understand that it is absolutely impossible that on this journey of 475 kilometers, there is only 75 kilometers more than as the crow flies. It is, in my opinion, very difficult to have a precise evaluation, and it is for this reason the manipulators choose this subterfuge. But I bet the direct route is much less than half the route by car route. There is also a parameter to understand about the blue point, which is our position on the GPS. The blue points move with the distance of the globe. It is for this reason that the curves are stretched. We can deduce that if our real speed is 100 km per hour, the blue dot moves at more than 200 km per hour on the GPS map. But obviously we cannot notice it since its speed corresponds to the force distances of the globe. The highway is over there in the background, and it goes down and it goes up.
On voit peut-être le panneau là-bas. Là. Et ça descend, ça tourne.
It's so much more distances. When I start to get interested in the subterfuge of distance, I didn't think it would be so much. It's impressive.
Sur ce site, là, Hervé. Et nous qui avons suivi la route.
Here you see the difference of the curves between the reality and the map.
On voit bien comme ça tourne, jamais sur la route directe, là ça descend. Désolé, j'ai pris un petit rhume ce week-end.
On the GPS as it turns quietly and in reality.
Vous voyez la coupe.
You can see the road in the distance.
Ça monte, ça descend, ça tourne. Ouais, c'est pas mal ça.
It's interesting, we go down southwest and again we drive for the long minutes where we do not approach the goal. Even I think we are moving away. Big detour, and we can think that while we are not advancing in the direction of the goal, the plane is always on the perfect direct route and without climb or descent.
L'avion, lui, file droit sur le but, sans virage, sans monter, sans descendre.
The red arrows is the route taken by the plane. In conclusion, we have seen in this capsule how the distance of the northern part of the flat Earth have been artificially enlarged to form an hemisphere with the help of pseudo-magnetic declination. For the southern part, the circumference of the flat Earth has been modified thanks to the subterfuge of the distances and the pseudo-magnetic declination into an ellipse. This ellipse under the 50s of southern latitude is certainly greater than the circumference of the sphere under the same latitude, but in my opinion not more than 25%. But let's keep in mind that the distance of 1 minute of latitude is certainly less than half that officially, so obviously, if the radius of the cycle is smaller, the circumference will also be smaller, and even more with an ellipse. The same reasoning must be applied to the equator, also smaller. So here we have the circumference of the flat Earth if we take the dimension of the globe. That is to say, if we take the globe and we deploy the 180 degrees of latitude on a flat surface, it will give a huge circle. If we take the unit of measurement as it is in reality, the minute of latitude is probably less than half that officially. Well, that will give us a much smaller flat Earth circumference. Then if we take the 50 south latitude, which is small on the globe, and the manipulators have reduced it by making us make an ellipse rather than a cycle thanks to the magnetic declination, and this shortens the distance around the Earth in the 50s of southern latitude to look like the globe.
Et ça raccourcit encore plus le tour de la Terre dans les 50e.
The purpose of the subterfuge is to create a very special unit of measurement, the minute of latitude, that only planes and ships used around the fake globe. This unit of measurement made on the basis of the latitude is the same force scale that we saw on the road maps. Then you just have to cheat with the speed of the plane and the boat, and you can then move with them on a support which has nothing to do with reality. That's all for this capsule. I hope you like it. The next capsule will deal with the relative speed of boats and planes. Thank you for watching.
Relative des bateaux et des avions. Merci de votre écoute.